All right, let's talk about trust. In a world with no central bank, no single authority calling the shots, how does anyone agree on what's real? It's a huge problem. And today, we're diving into the incredibly clever solutions that make it all work, the consensus mechanisms that are the true heartbeat of any blockchain. So here's our game plan. We'll start with why trust is such a big deal in the first place. Then we'll look at the OG solution, proof of work, see how things got way more efficient, check out how private networks play by different rules, and wrap it all up with the big trade-off every single network has to make. Okay, so let's start at square one. At the absolute core of any digital currency, you've got this massive challenge, the trust problem. Without a central figure to lay down the law, you have to invent a whole new way for everyone to get on the same page and agree on the rules. I mean, think about it. You can take a digital photo, right? And you can copy it 1,000 times, email it to everyone you know, no problem. But what if that file was a digital dollar? If you could just copy-paste your money and spend it over and over, well, that currency would become totally worthless, fast. That exact problem, that's called double spending. And it's the thing that Satoshi Nakamoto's original Bitcoin white paper was built to solve. It was literally the biggest obstacle standing in the way of a true peer-to-peer digital cash system. So, what's the solution? A consensus mechanism. You can think of it as the engine of the blockchain. It's a system of rules that lets thousands of people who don't know or trust each other agree on one single version of the truth. It's what makes the whole thing work. And that brings us to the first and, without a doubt, the most famous consensus mechanism out there, proof of work. This is the beast that powers Bitcoin and pretty much kicked off this whole revolution. So, how does it work? Well, imagine this. All the recent transactions get bundled together into a block. Then, a whole bunch of powerful computers, called miners, start a frantic race to solve an incredibly hard math puzzle. It's kind of like trying to guess one specific grain of sand on a massive beach. The first one to find it gets to add the next block to the chain, and they get a reward for their effort. And here's the beautiful part, the real genius of the system. It takes a ridiculous amount of work and electricity to find the answer to that puzzle. But once someone finds it, the rest of the network can look at it and go, yep, that's it, in less than a second. That imbalance is everything. It's what makes the whole network so secure. But, and this is a big but, that security comes at a staggering cost. Proof of work uses an insane amount of energy. We're talking the same amount as entire countries. Plus, it's not exactly fast. A new block on Bitcoin takes about 10 minutes. So naturally, people started asking, there's gotta be a better way, right? And that search for a better, more efficient way, well, it kicked off a whole new wave of innovation, a new generation of consensus mechanisms, all trying to solve proof of work's biggest problems. The most popular alternative you'll hear about is proof of stake. The idea here is totally different. Instead of putting up massive computers and burning tons of electricity, validators lock up, or stake, their own money, their own cryptocurrency. The network then chooses validators to create the next block, usually based on how much they have at stake. So it's not a race of computing power, it's a race of economic commitment. Then you've got another cool evolution, proof of authority. In this system, you're not staking money. You're staking something arguably even more valuable, your reputation. Validators are known entities, and their identity is on the line. This is super efficient, but it really only works in private networks where you already know and trust the people involved. And trust me, the creativity just keeps going. You've got wild ideas like proof of capacity, where you stake your empty hard drive space. There's even proof of burn, where people literally destroy their own coins just to earn the right to mine. It's a field that is constantly experimenting. So that brings us to a whole different side of the blockchain world. Private, permissioned networks. See, when you're not dealing with millions of anonymous strangers, the rulebook can change completely, and you can get things done a lot faster. And this is a really important distinction. Public chains like Bitcoin, their main goal is to be as decentralized and unstoppable as possible. But private chains, the kind big companies use, they care way more about raw speed, efficiency, and privacy among a small, trusted group. One of the big names in the private space is Raft. Now, unlike the competitive systems we've been talking about, Raft is all about cooperation. The network nodes elect a single leader, and that leader's job is to manage everything. The others just follow along. As long as that leader is doing its job, you get consensus almost instantly. It's perfect for business use cases. Another key player is PBFT, or Practical Byzantine Fault Tolerance. This one is designed for a worst-case scenario. What if some of your own nodes turn against you? It's based on an old thought experiment about generals surrounding a city needing to agree to attack, even if some of them are traitors. PBFT uses a complex voting system to make sure the loyal nodes can always reach an agreement no matter what. So, after all that, proof of work, proof of stake, raft, which one's the best? Well, turns out that's completely the wrong question. The reality is, it's all about one big trade-off. And this is probably the most important thing to remember. There is no perfect consensus mechanism. Every single one is a balancing act. You're constantly trading off between things like security, speed, how decentralized you want to be, and how much energy you're willing to burn. So just to recap it all, proof of work gives you rock-solid security for public networks, but at a huge energy cost. Proof of stake slashes that energy use, making it great for more efficient public chains. And then you have proof of authority in systems like Raft, which give you incredible speed and are perfect for private networks where everyone already knows each other. Which really just leaves us with one final massive question. As this tech continues to grow and change the world, which of these things will we decide matters most? Will the future be built on maximum security, blazing fast speed, or true decentralization? The answer to that, well, it's going to shape everything.